everyone, this is your Gayatri madam. I hope you liked my previous video. In the last video, we learned how to find the complementary function for the different types of roots. Let us solve some problems in this video. I hope everyone enjoyed my video. So subscribe my channel and continue to follow my videos. Okay, here the general solution, already I discussed the general solution of the given differential equation in the last video. So just let us reconsider. The general solution of differential equation f of d into y equals to q of x is y equals to y complementary function plus y in particular integral. So complementary function, by taking left side part we will get complementary function. By considering the right hand side part we get the particular integral. So next point, the general solution of differential equation f of d into y equals to 0. If you observe these two, here right hand side part is there, q of x is not equals to 0. Here q of x equals to 0. So this is we call homogeneous differential equation. If f of given differential equation is homogeneous differential equation or in the form of f of d into y equals to 0, then the general solution is y equals to ycf only. Here particular integral becomes 0 because q of x is not in the differential equation. Okay, now let us see some problems how to write the complementary function. So first problem, solve d square y by dx square minus a square y equals to 0, where a not equals to 0. Observe the differential equation order, what is the order and what it is. Either q of x is there or q of x is not there. So now here q of x is not there. So now we have to find the general solution. Here they asked on solve the differential equation. That means we have to find the total general solution. So the given differential equation order is 2, since because the higher differential equation is 2. So the given differential equation can be written in the form of f of d into y equals to 0. We have to write in that form. So by taking here, let d square by dx square equals to d square. So now put here, the given equation can be written d square y minus a square y equals to 0. Take y outside, so we get d square minus a square into y equals to 0. Is of the form f of d into y equals to 0, where f of d equals to, what is f of d? D square minus a square. Now we have to find the complementary function. To find the complementary function, we take the auxiliary equation. That is f of m equals to 0. We know f of d, that is d square minus a square. So f of m equals to, replace d by m, we get m square minus a square equals to 0. M square equals to a square. M equals to plus or minus a. M equals to plus or minus a. That is m equals to plus a and minus a. So these are the roots. See how many roots we get? 2. Since because the differential equation is second order differential equation, compulsory we get 2 roots. Okay. Or real and different roots. Real and different roots. Since A is in the problem they mentioned A not equals to 0. So it is real and different roots. So how to write the complementary function yc equals to, for different roots, how to write complementary function? We have two roots. You have to take two arbitrary constants c1 e power ax plus c2 into e power ax. Since because in the given differential equation x is independent variable, y is dependent variable. X is independent variable, y is dependent variable. So yc equals to c1 complementary function yc equals to c1 e power ax plus c2 into e power minus ax. Therefore, this is only complementary function. Therefore, the general solution is y equals to ycf only. If you want, you can put yp. Since because here yp becomes 0. So y equals to ycf only. Since q of x equals to 0 here in this problem. So y equals to c1 e power ax plus c2 e power minus ax. Sorry, here I did not put. So c1 e power ax plus c2 e power minus ax. See, observe the general solution. In the problem, x is independent variable, y is dependent variable. So the general solution of the given differential equation means what? By eliminating the derivatives, the answer should be dependent variable is equals to in terms of independent variable. Here C1 and C2 are where C1 and C2 are arbitrary constants See, second order, this is second order differential equation. The solution contains two arbitrary constant compulsory. If it is first order differential equation, only one arbitrary constant we take the solution. So this is the general solution of the given differential equation. This is the solution of the given differential equation. Now next problem. Go to the next problem. Solve second problem. Solve d square y by dx square minus 8 into dy by dx plus 15y equals to 0. Okay. So now solution. Now the given equation can be written in the form f of d into y. So d square by dx square you can put d square y minus 8 into dy plus 15y equals to 0. So d square minus 8d plus 15 into y equals to 0 is of the form f of d into y equals to 0. Here also q of x equals to 0. Q of x equals to 0. So where f of d equals to d square minus 8d plus 15. Take the auxiliary equation. To find the complementary function, we have to take the auxiliary equation, that is f of m equals to 0. That implies m square minus 8m plus 15 equals to 0. Now solve this equation. This is a quadratic equation. You can solve it. See, by manual you can solve or by calc you can solve. So now m square. 5 3s are 15. 5 plus 3 8. So 5m minus 3m plus 15 equals to 0. So m into m minus 5 minus 3 take outside, m minus 5 equals to 0. So m minus 5 into m minus 3 equals to 0. So m equals to 3 comma 5. Tell me, what are the types of roots? Are the real and different. Real and 3 and 5 are different roots. They are not equal roots. So how to write the complementary function? YCF equals to C1 e power 3x plus C2 e power 5x. Okay. The general solution is y equals to YCF plus YPI. So that implies y equals to YCF only since YPI equals to 0. So therefore y equals to C1 e power 3x plus C2 into e power 5x, where this is the general solution. Solve means we have to find y, not even YCF, YPA, y only. Okay, particularly some problems they mention find the complementary function of. Let us see the problem, one problem. So where C1 and C1 comma C2 are arbitrary constants. Okay. Now next problem. Third one. Solve d square plus 6d plus 9 into y equals to 0. D square plus 6d plus 9 into y equals to 0. See, this is the given differential equation is already in the form of f of d into y equals to 0. No need to convert the given differential equation f of d into y. It is already into f of l, already in f of d into y form. So given differential equation d square plus 6d, given a differential equation d square plus 6d plus 9 into y equals to 0. Here also q of x is 0. 0 is of the form f of d into y equals to 0. So now where f of d equals to, what is f of d here? D square plus 6d plus 9. Take the auxiliary equation. The auxiliary equation is f of m equals to 0. That implies m square plus 6m plus 9 equals to 0. So already you think m plus 3 whole square, this is okay. So this is m plus 3 into m plus 3 equals to 0. So m equals to minus 3 comma minus 3. So observe, I told you already it is second order differential equation. So compulsory you will get two roots. And in the solution two arbitrary constants will be there. If it is third order differential equation, compulsory it has 3 roots. More than 3 roots will not get. 3 roots exactly, and less than 3 roots will not get. Exactly 3 roots will get if it is third order differential equation. And in the final solution, general solution, 3 arbitrary constants will be there. Now observe here what are the types of roots. These roots are real and equal. Roots. So how to write the complementary function if roots are real and equal? Two roots are there. We have to take two arbitrary constants. For equal roots, you have to consider c1 x power 0, c2 into x into e power minus 3x. Okay. Here y equals to, the general solution is y equals to YCF plus YPI. So that implies y equals to YCF only, since because particular integral is 0. So that implies y equals to C1, x power 0 is nothing but 1, I am not writing, C2x into e power minus 3x, where C1 comma C2 are arbitrary constants. So this is the solution. Now next one more problem. Fourth one. Solve d cube y by dx cube minus 3 into dy by dx plus 2y equals to 0. So this is third order differential equation. So now the equation how to converting into f of d into y equals to 0 form. So that is d cube, y is there, only d cube by dx cube you take y, d cube y minus 3 into dy plus 2y equals to 0 is of the form d f of d into y equals to 0, where f of d equals to convert this d cube minus 3d plus 2 into y equals to 0. F of d equals to d cube minus 3d plus 2. The auxiliary equation is f of m equals to 0. That implies m cube minus 3m square plus 2 equals to 0. See, actually what the students are doing mistakes here. In the flow, you consider, you solve this problem like you assume that it is a quadratic equation. M square minus 3m plus 2. Immediately you will write that 2 and 1. Okay, but it is not. It is not a quadratic equation. It is a cubic. So m cube minus 3m square plus 2 equals to 0 it is. So you have to solve this problem by synthetic division, by manually if you want, or by calc you can solve this problem. In calc there are options solving the polynomial. You put order, so you can enter the coefficients and you will get the solution. I will show how to solve through calc. I will show in the next video. So now synthetic division how to solve. We have to take the coefficients. M cube coefficient 1, m square coefficient minus 3. See here this is not m square, m minus 3, and m square coefficient is 0. M cube coefficient is 1, m square coefficient is 0, m coefficient is minus 3, constant is 2. Now you have to take one value which this equation is satisfying, which the value satisfying this equation. So now here suppose take m equals to 0, and substitute here 2 we will get, which is not equals to 0. Take m equals to minus 1, substitute here minus 1 plus 3 plus 2, which is not equals to 0. Take m equals to 1 and substitute there 1 minus 3 plus 2, which equals to 0. So if you take m equals to 1, then it is satisfying. So put m equals to 1 here and start the synthetic division. Put 0 first place, first place we have to put 0. Here we have to add. 1 plus 0 1. Here we have to multiply and put the solution here. So 1 1s are 1 and add 1. 1 1s are 1 minus 2. 1 into minus 2 is minus 2. Compulsory you will get 0 here. It should get 0 here. Okay. So if you take correct value here and start the synthetic division, compulsory will get 0. Which value you have to take here? That is by calculating this, by verifying this, you will get one value. Take that value and start the synthetic division. Okay. Now we get m equals to 1 is 1 root and m square plus, here 1 is there, so we write m square, and next 1 is there, m, next minus 2 constant, it is 0. Okay. See here m square, already m cube is converting into m, 1 root is there, 1 root we got 1 root, m equals to 1 is 1 root, so m cube is becoming m square. So m square plus m minus 2 equals to 0. Now this is we have to solve. M square plus 2m minus m, 2 1s are 2. Okay, m into m plus 2 minus 1 of m plus 2 equals to 0. So What are the roots? We get m minus 1 into m plus 2 equals to 0. So total how many roots we have? Here one root is there. So that is m equals to 1 and m equals to, for this also m equals to 1 and m equals to minus 2. 1 comma 1 comma minus 2. And then two roots are equal and another one is different. See, as I told that this is third order differential equation. We get compulsory, we get 3 roots. So now 1 comma 1 is repeated 2 times. So how to write the complementary function? For 1 comma 1, c1 plus c2x into e power x plus, already c1 c2 over, so c3 into e power minus 2x, or you can write like this, complementary function equals to c1 e power minus 2x plus c2 plus c3x into e power x, where c1 comma c2 comma c3 are arbitrary constants. Where c1 comma c2 comma c3 are arbitrary constants. I hope everyone understood these problems. Let's see in the next video some more problems about the complementary function. I like everyone understood this. So if you like my video, subscribe my channel and